Afternoon, everybody. I'm Ginger Nickerson, the Urban and Community Forestry Programs Forest Pest Education Coordinator. Thank you for joining us today on this gorgeous day and spending a little bit more time inside on a camera. Um, so Josh Halman, the Forest Health Lead for the Department of Forest, Parks, and Recreation, is going to be speaking with us today about the current status of emerald ash borer in Vermont. And Josh is normally based out of the Essex FPR office, but today he will be speaking to us from his home in Jericho. So just before we start, I want to let you know that all of the audience attendees are muted, but we welcome your questions. And if you look in the control panel on the right-hand side, there should be a little box that says questions. If you click on the down arrow, then you can enter your questions in there and you can type them in anytime and we'll address your questions at the end of Josh's presentation. So without further ado, I will turn things over to Josh Halman.
Great, thanks, Ginger. Appreciate the opportunity to provide this talk today, and I'll echo Ginger's sentiments about thanking folks for tuning in when it's so glorious outside. But hopefully it can give you an update today, excuse me, on the status of emerald ash borer in Vermont, and kind of what our response is to it and what our efforts are currently for monitoring the insect and its spread throughout the state. So emerald ash borer in Vermont, many of you may be familiar with the insect in general, and you may be familiar with its history in Vermont. It was originally detected in the state back in February of 2018 in the town of Orange. And like I mentioned, this was the first detection in the state. And since that time, we have found that emerald ash borer has now been confirmed in 10 counties in Vermont. And I say confirmed in 10 counties in Vermont, but you might look at this map on the left here and say that looks like that might stretch a little further than that. So I want to orient you a little bit with this map because this is a tool that we've been using for some years now, and we update it regularly, where the center of each one of these circles is a confirmed detection of emerald ash borer in the state. And the larger circles surrounding that, so both the orange and the yellow that are present there, those two combined make up something that we call the infested area. And going 5 miles out from that point of detection is what we term the confirmed infested area. So areas where we expect emerald ash borer to be present, even if we've not detected it in multiple trees in that location. And an additional 5 miles out from that is what we call our high risk areas. These are areas where, although we have not found the insect, we expect that if it's not in that area already, that in the next couple years, it could be present in that area. And so when considering those high risk areas in the state, we see that those areas touch 13 of our 14 counties in Vermont. So really there's not an area of Vermont that is immune from having emerald ash borer present in it at some point. And at this point in time, there are certain locations in most counties where there is a likelihood that emerald ash borer could be present. Spread within the state occurs much like it does in other parts of the country, where there is some natural spread that occurs, and you can kind of see that in that orange detection area, the town of Orange, that is. This area where you have multiple detections and it's slowly spread out from there. But human activity, as many people know, is the largest spreader of emerald ash borer throughout the region and throughout the state as well. One thing that I like to point out is that despite this seemingly expansive coverage of emerald ash borer in the state, there are still a lot of areas that do not have emerald ash borer. And even those areas where we have confirmed emerald ash borer, there are varying levels of severity and varying levels of infestation and impact in those spots. And so one thing that we're actually currently working on is developing a more nuanced map that looks similar to what we have on the left here, but has some shading differences in those areas where we've detected emerald ash borer or where there's a high risk area. That'll give a little more clarity on where the areas are within the state that have the most severe dieback or mortality even of trees compared to those that may have just had one insect that was identified on a trap of some sort. So that new map you can expect to be released in the next month or so. And I'll talk a little bit about the resources where you can find some of this information as we go along in the talk today. I thought I'd talk a little bit about our approach and a little bit about the history of emerald ash borer in Vermont and our monitoring efforts as well. Despite the fact that I'm from the Department of Forest, Parks, and Recreation, this is not just one agency that's focused on emerald ash borer in the state. It's actually a team approach. So we have folks from the Vermont Agency of Agriculture, Food, and Markets, from FPR, from the U.S. Forest Service, from the USDA APHIS Plant Protection and Quarantine, as well as UVM Extension, all involved in monitoring efforts, outreach efforts. So it is a big group that's working on this. And some of you may have heard that up until recently, and I think just a few months ago, there was this rather large, expansive federal quarantine in place for those areas affected by emerald ash borer. A couple months ago, this was actually removed. The USDA determined that they were no longer going to enforce this federal quarantine. And while that might sound a little scary, the good news for us in Vermont is that it actually doesn't change that much of how we operate and how we've been dealing with emerald ash borer and ash products in Vermont. One thing that's worth noting is that despite this quarantine no longer being in place, it is still not allowed to move visibly infested wood throughout the state or across the state line. And the importation of firewood into Vermont is not allowed either without a permit in place or a waiver in place. So those things don't change despite the federal quarantine being lifted. And in addition to that, we still have these measures that we've put in place to help the public with how to be responsible with moving ash material in general. So we have our slow the spread recommendations that I'll briefly go through later. And you'll see a number of our monitoring and response efforts to those areas where emerald ash borer is suspected. And you'll hear a little bit today about our biocontrol efforts that are newly implemented. That began last year. So that's kind of the overview of it, and I'll get into the details a little more here. But wanted to give you a little brief history of what we've been doing with emerald ash borer in Vermont. So as you likely know, emerald ash borer was first detected in Michigan in 2002. And on the heels of that, in 2003, we began inspecting sites of concern throughout Vermont with heavy ash populations. In 2008, this is the data that I could find. This is as far back as the purple traps appeared in Vermont, but it's possible they were here earlier. But this is when there was a very concerted effort that began hanging these purple traps to detect emerald ash borer in the state. And this was largely taken on by the USDA and the Agency of Agriculture here. And in 2009, we started kind of an interesting monitoring effort that was a biological monitoring effort. That is to say that there is a ground wasp, this scientific name of Cerceris fumipennis, which actually feeds on insects in the same family as emerald ash borer. So this is the Buprestid family. And we established a network of sites where these wasps occur. And this actually wound up being a lot of small baseball fields or sandy areas where they burrow in. And the monitoring effort there was to identify where these wasps emerge. And it's oftentimes a good idea to look around those holes in the ground, basically, where they're emerging, because the adult emerald ash borer, like you can see in this picture here, would be ringed around there if they were to capture that. So it's kind of an interesting monitoring effort that we started in 2009. We didn't have any positive confirmation, obviously, from that, but it was still a unique effort, and it actually built quite a bit of education with the public as well, because this used a fair number of volunteers to establish these sites. In 2011, we started doing a more extensive use, started having a greater extensive use of what are called trap trees. These are trees that you girdle, so you cut the bark and the phloem away from these trees early in the season, and that ultimately attracts insects by the fact that that stresses the tree. So the tree sends out certain chemicals that attract the insect to the tree, and at the end of the season, we would cut those trees and peel them and see what the results were if we found any larvae in the trees. And that effort continues to this day. We do that every year at a number of sites around the state, and I'll show you where we've done that most recently a little bit later. In 2015 and 2016, we continued our trapping, but we used additional traps, which included these green funnel traps you see here, focused on high-risk areas that were in portions of the state where we would have predicted emerald ash borer to first come in based on its proximity to other infestations. So this was largely in the northwest of the state and the southwest of the state. Again, in those years, did not catch any emerald ash borer. But then, of course, in 2018, we found emerald ash borer in orange, so it was nowhere near those two areas that we thought were high risk. But we, on the heels of that initial detection, we set out to do some delineation surveys around the detection centers to see how far emerald ash borer had spread, if it was much more extensive than that one location in orange. And all this is really just to say that despite finding this only in 2018, we've been working on emerald ash borer projects for a long time in Vermont. And I think we've done a very good job of educating the public and making people aware. We still get many, many calls every year about suspect insects or dieback in ash trees, and we want this to continue. We want to be able to know where emerald ash borer is on the landscape. And so these efforts, I think, have really helped with public awareness, and we're grateful for that. But now, after 2018, we obviously have emerald ash borer in Vermont, and in certain locations in the state, these are some of the scenes that you can see. These are all trees from Vermont, and going from left to right here, I'll just describe some of the symptoms that we see. You see the S-shaped galleries, which are really textbook for emerald ash borer, that's underneath the bark there, right? So they're feeding as they make that track in the tree, and when populations are high enough, that's what ultimately will kill the trees. Some other signs that emerald ash borer could be present include this center picture here. We're seeing the bark kind of picked away by woodpeckers, actually, and those are woodpeckers that are looking for the emerald ash borer larvae. They're actually very good at cueing in on where those are in an infested tree, knocking the bark off and feeding on them. So that's a great detection tool as well. And you can see in that center picture that it's not terribly obvious. There's a lot of holes there, but sometimes you will find full sides of trees with so much woodpecker activity that the bark is completely off the tree. And we call that blonding when that happens, because it looks like a blonde color there. And you can see evidence of that in the top right there, as well as the exit hole of emerald ash borer, that textbook D-shaped exit hole. And as I mentioned, in some of those areas where there is heavy woodpecker activity, you can look on the ground at the base of the tree and see these shards of bark that have been broken off the tree. So that's all to say that in Vermont, we have varying symptoms of emerald ash borer and various levels of severity. So I want to take a minute to go through what it looks like as emerald ash borer kind of progresses through an area, because something that often comes up is that people, have seen the headlines about emerald ash borer. They've heard about it from, friends in a different part of the state, but they're not seeing any effects on their trees, and they think, why bother worrying about it at this point? And kind of the reason for that is that when emerald ash borer first gets into the trees, it doesn't cause immediate damage. It takes some years for the damage to actually be visible. And so in this schematic, you can kind of see how that progresses, that, it can take a few years of the insect being present. It's still feeding on the tree, but it's not having anything that shows up in the crown or any dieback of branches until maybe year 3 or 4. And so in general, we tend to say that once you found emerald ash borer in a tree, it's likely been there for 3 or 4 years at a minimum. And you can see what happens after that 3 to 4 years is that the decline in those trees is rather rapid. So I think it's important for folks to be familiar with what you can do to protect your trees, or how close the insect might be to your land, and just familiarize yourself with the options that you have as a landowner, in terms of how you would treat your ash, and what could possibly be on the horizon for you should emerald ash borer get into your trees. And this is just one other schematic that I can't take credit for, but it's basically showing how the populations of emerald ash borer build over time. And you can see here that it takes over 5 years for the population of emerald ash borer to get even close to the height of the population density to which it succeeds. So if we overlay another curve here looking at mortality of trees associated with this, you can see that it could take over 5 years before you're seeing any mortality in a site with emerald ash borer. So sometimes the EAB are in there, but they're pretty hidden, and the effects can be seen pretty quickly after the initial impacts are detected in the upper portions of the crown. So another question is often how quick does the insect spread? Right? I showed in that initial map how emerald ash borer spreads, or a location where emerald ash borer appears to be spreading rather naturally out of that orange detection. And the insect is not a great flyer. An infestation typically spreads about 1 to 2 miles per year based on the biology of the insect. But of course, as we know, the movement of firewood that's infested can spread the insect hundreds, if not thousands of miles, depending on where somebody's moving that wood. So human facilitated transport is a big problem with emerald ash borer. And it's one of the reasons that we have so much outreach that occurs to educate people on why it's best to leave your firewood at home. And if you're traveling somewhere to camp, to be purchasing that firewood on site rather than moving it from your home. And for that reason too, it's kind of difficult to predict, when emerald ash borer might be coming to your neighborhood, because it has the potential to be rather sporadic with where it appears because of human-induced movement. It's best to just familiarize yourself with how to identify emerald ash borer and some of the considerations to make if you had any intention of harvesting ash, or if you wanted to protect your ash. So I'm just going to be planting the seed here for folks to familiarize yourself with some of those options should emerald ash borer get into your land. And one of the tools that we have that can provide a lot of this information are what we call our slow the spread recommendations. And that's what you're seeing here on the right-hand side. It's a pretty long list and pretty detailed. I have the bottom here that if you want to take a closer look at this, along with a number of other really valuable resources, you can go to vtinvasives.org, which is a great clearinghouse for information on all sorts of invasive species, but in particular, there's a lot for emerald ash borer at the site there. But to get back to these recommendations, the goal of these, as I mentioned at the beginning of the talk, is to slow the spread of emerald ash borer in the state. And we do have a lot of spread to slow. And what these are outlined to help with are the transport of ash materials. And you can see in the table that there are a number of different ash materials, from saw log to roundwood to chips to firewood. And we've developed these with science in mind. So based on the type of wood that you're transporting, the size of it, as well as the flight season of emerald ash borer itself. So because we're a little further north than some of the detections, it's been shown that the flight season for emerald ash borer in Vermont really begins on June 1st. So we've got a couple weeks here until flight season is underway. But because of that, the way that ash products are transported is pretty different between the non-flight season and the flight season, as you can imagine. There's greater restrictions on what you can do when the flight season begins, because that increases the risk, the risk of spread as you're moving products throughout the state. So these are very helpful, I believe, and I would familiarize yourself with these, especially if you plan on moving any of these products that are listed here in the left part of the table. So that's one piece of outreach that we've done that I think is widely available, and it seems that people are taking it to heart. Another monitoring program and outreach program that's been really successful in educating the public is the Purple Trap program. It's pretty hard to miss these if you drive by on the road and you see a big purple triangle hanging in a tree. And so as a result of that, it's really brought up a lot of questions from the public of what are those, what are they doing? And in Vermont, the Purple Trap program works with volunteers to help hang the traps and monitor them. Basically, the way the traps work is that they are a 3-panel trap, and on the outside of them, there's a very, very sticky coating that basically snags the insect if it were to fly into that purple. And it's been shown that purple actually is an attractant to the insect. So early on, there were traps that were hung without any kind of lure or anything like that, just the color, and they still detected some insects. But we're now involved with the program where there are lures, natural chemicals that attract emerald ash borer, not from a massive distance away, but they do have an attractive ability. And we hang those with the traps to potentially bring EAB to somewhere where we can identify it. So the point there is that these aren't the strongest attractants, so we're not pulling in emerald ash borer from far away to a site that does not have emerald ash borer presently. These will only bring in those local insects that detect this. So it's not like we're spreading the insect anywhere, but in fact, we're just documenting whether or not it is present at that site where the trap is hung. So I mentioned that there was some delineation that took place of emerald ash borer following that 2018 detection. And this map is showing you obviously where all the purple traps in the state were following that. A huge number were deployed to see what we might have in the state, 609 traps to be exact. And what was found from these were that, as you might expect, close to Orange, there were detections in Groton. And down on the southern edge of the state, the southern border with Massachusetts, there were a couple emerald ash borer that were found in a trap as well. And so those were really the first two locations where we said, yes, we know that emerald ash borer has been found in Vermont. And so we continued with this program to get volunteers hanging traps and to see year after year what that might look like and what the spread might look like in Vermont. And so in 2019, there were 78 traps that were deployed in about 30 towns. We found one new location that was in the northwest of the state up in Alburgh. And in 2020, 114 traps in 50 towns were deployed, and EAB was collected in 3 new locations as a result of that. Plans for 2021 have 112 traps planned in 63 towns. And those, as I mentioned, will be going up during the flight season, because that's when you'd be catching them, is after they start flying. So beginning June 1, we might expect to see something caught in traps, if not just to have all our traps up. So during flight season is when these are effective, and the way these are monitored is that the traps go up in early June. Halfway through the summer, the traps are lowered. They're inspected for emerald ash borer, and any suspects are put in vials and vials with alcohol to preserve the insect, and sent to us to identify. And At the same time, the lure is changed so that it's effective for the rest of the growing season. And at the end of the season, traps are lowered, inspected again, and removed from the site, so they don't stay up there all winter. So we'll see what this year brings. I expect we will have some catches, and that helps us greatly determine how the insect is spreading and where it's spreading. So really the goals of the Purple Trap program are to delineate existing infestations, and to monitor new infestations and alert towns and municipalities when we find emerald ash borer close by or in their towns. And of course, as I've mentioned a few times now, raising public awareness of EAB is a key goal of using these highly visible purple traps as well. So it's been a great detection tool. They've been used throughout the country, and I'm glad to see that we're continuing to use them here in Vermont. I mentioned trap trees at the outset as well, which are another monitoring tool that we use. I mentioned that we girdle them, remove the bark, and that stress attracts insects to the tree where they lay eggs. The emerald ash borer, the adults lay eggs on the bark of the tree, and those eggs are actually really quick to hatch. They can hatch in as little as 2 weeks after being laid. And what happens then is that the larvae burrow into the bark, below the bark, and they start to feed on that cambium. And so what we do in the fall is we cut the trees down and we very slowly and methodically peel the bark with draw knives, looking for evidence of the insect in the trees. And last year, so in 2020, we at FBR established 38 girdled trees in the spring. You can see those locations on the map here. And we focus these largely on state or municipal lands just for ease of access. And what this did after we dropped them in the fall and we peeled them, we found 2 new detections based on these, one in Groton and one in Bennington. So definitely an effective tool for us. We'll be putting these out again this year on state and municipal lands. And again, it's the same kind of idea as the purple traps, is that these aid in detecting those areas where emerald ash borer is currently. One thing that I haven't mentioned yet, but is perhaps one of the most helpful and most critical components of our monitoring efforts in the state for EAB, is responding to requests from the public that have either a ash tree that is showing rapid signs of decline, or an insect that looks similar to emerald ash borer, or even just exit holes on a tree that look like those emerald ash borer exit holes. And so we feel these by a number of means, whether it's being referred by somebody, having staff that have noticed something, and they reach out to us. But one tool that's really excellent is this report it function at the btinvasives.org website, where if you do have a suspicious tree or a suspicious insect, you can submit information and photos especially to help us narrow down whether or not this is something to be concerned about and whether or not that requires a visit. So I encourage you, if you do have suspects that appear that you run into, that you use that tool and take plenty of photos. Photos really help us figure out what we have going on there and whether or not a site visit is required. So that's a very excellent tool that's available to all of you. But since the fall of 2019, we've been using a phone app basically called Survey 123, which is a way of cataloging these sites that we visit. And since then, we've had 95 visits to spots across the state, 56 last year. And most recently, using this tool and using the report it function resulted in 2 new finds, one in Richmond and one in Rutland. So yet again, another great tool for folks to use, and has really helped us get a pretty comprehensive look at those sites across the state. So that's been a really great tool for us. Which brings us to probably our newest tool for for mitigating the impacts of emerald ash borer on the landscape of Vermont. And that's something known as biological control, or biocontrol is how I'll refer to it mostly as we go along here. Biocontrol of emerald ash borer. So before we get into that, I mentioned the eggs kind of briefly, and I show this in case folks aren't familiar with the life cycle of emerald ash borer, that as I mentioned, the insect lays its eggs on the outside of the bark, and those larvae tunnel into the tree where they live for anywhere from 1 to 2 years, depending on the climate. They, during this process, are feeding on the phloem and the cambium of the tree, making those S-shaped galleries, and then ultimately they pupate and they emerge out of the tree via this D-shaped exit hole. And they fly and mate, and then the whole process starts again. And the reason I show this life cycle at this point is because as I'll go through the details of the biocontrol program and the mechanics of that, two of the most vulnerable life stages of emerald ash borer are the eggs and the larvae, because they're really located on the tree. They're not moving around outside of the tree at that point. So it's a really important part of their life cycle that's probably the easiest to target for a predator or for something to disrupt their life cycle. And so I'll talk a bit here about exactly what biocontrol in general is. So as a broad concept, not exclusive to emerald ash borer, biocontrol is the release of what are known as parasitoids that impact the pest of concern. So in this case, the pest of concern would be EAB. Parasitoids would be a couple of these species that you see here on the right. Specific biocontrol agents, like I mentioned, they impact a particular life stage. And really the goal of using a program like this is to either reduce or eradicate the population of this pest of concern. With emerald ash borer, it's important to know that the biocontrols that we have in place right now, they are not meant to eradicate the entire population of emerald ash borer in the state. Unfortunately, EAB is successful enough that we've not found a parasitoid that could completely eradicate it. But the goal of the biocontrol program for EAB is to reduce the populations of EAB such that we can reduce the progression of symptoms and reduce the rate of mortality in some of these stands, at the same time as giving a greater chance for regeneration of ash species on the landscape. So by virtue of these insects taking advantage of the EAB population and killing much of that off, it gives the younger trees, saplings, a better chance at surviving into the future and growing into mature trees. And I should mention as well that with the lifting of the federal quarantine, that a lot of the effort that the Forest Service and the USDA are putting into emerald ash borer efforts, biocontrol is one of those efforts that they are greatly supporting and trying to bring these into the landscape more and more so that they can help reduce those EAB populations. But for EAB, the method at which these parasitoids can actually affect emerald ash borer, particularly the two that you see here on the right, these are both larval parasitoids, and I'll go into the details of each species in a moment. But so both of these take advantage of the larvae in the tree, and you can see that both of them have this kind of what almost looks like a stinger, but is known as an ovipositor, with which they lay their eggs below the bark, so they're able to pierce the bark and lay their eggs directly into emerald ash borer larvae, which is pretty fascinating. And as those eggs develop, they begin to hatch out of the larvae. And the hatching of the parasitoid eggs basically kills the EAB larvae. And I'll show you a picture here, which is showing that. So it's a little squirmy, but it's pretty fascinating once you take a look at it. So each of these arrows indicate a different species of parasitoid that is actually present within an EAB larvae. That's the larger shiny object that you're seeing there is the EAB larvae. And those little leg-looking things coming out by the S arrow are that's the egg hatching and the development of insect known as Spathius. And the one on the right here that with the T is one known as Tetrastichus, and that's what you see in the upper right there. So as those hatch and develop into their own larvae, they are killing the EAB larvae itself. So that's the method of function for these. And so I mentioned that there are a number of species that are involved with these biocontrol efforts. here are the four that are really in play right now: Obius agrilli, Spathius agrilli, Tetrastichus planipennisi, and Spathius galeni. And last year was our first year with Biocontrol here in Vermont for EAB. And the only species that we were able to release last year was Tetrastichus planipennisi. So this is a very small wasp, and I'll kind of go through some of its characteristics here. So you can see just how small that is on somebody's fingernail there. You would probably never notice this out in the woods walking around at all. And some of the characteristics that are important to note about this insect is that it is a stingless wasp. All these wasps that are involved in the biocontrol program are stingless. It is a native parasitoid to emerald ash borer from China. And what's really unique about this is that it has multiple life cycles per year. As you saw from the previous schematic that I showed, emerald ash borer has a life cycle of 1 to 2 years. But the fact that these are having multiple life cycles per year enables them to knock down the population of those EAB larvae even better. And one thing that is often a concern when you're discussing something like biocontrol is what are the effects on those non-target species. And for this species in particular, it only targets EAB. It does not even target other insects within the Buprested family. So it's a very targeted, safe biocontrol species to be deploying here in Vermont. I mentioned a couple other players with this, but where do we get these insects? We get these parasitoids from a USDA laboratory in Michigan that's been rearing these insects for years now. And that's the whole purpose of that lab that's present there. And they really want to get these parasitoids into as many infested areas as possible, with preference to those counties that haven't had any parasitoids released in them yet. There's no fee for participating in this program, so that's a big win-win. And perhaps an even bigger win for us in Vermont is that because we detected emerald ash borer rather late compared to many states, we have a lot of data and experience from other states showing that there have been no ill effects from introducing these in other areas. So we are the 30th state to be releasing these. And to this date, there's not been a negative consequence shown for releasing these whatsoever. But in fact, there is quite a bit of data showing how these reduce the emerald ash borer populations where they are present. So it is a good species for this for sure. I want to take a second and mention one of the sites where we have released this insect, and that's at L.R. Jones State Forest. That's up near Orange. It's in the Plainfield area, if you're not familiar with it. So near that initial detection. And as you can see from this picture with one of our protection foresters, there's plenty of EAB activity in this forest. And we selected this site as a release site because of a couple things. One, we knew that emerald ash borer is present there. But in addition to that, we know that there are a variety of size classes and ages of ash trees within this forest. So this shows that there's plenty of material for the parasitoids to lay their eggs into, but that there is that generation of new trees that the establishment of the parasitoids could help protect going into the future. So here's some more images of that site. You can see that there's not only variation in the sizes of the trees, but in the levels of infestation. On the left, you can see some trees that have had emerald ash borer in them for quite a while. And on the right, you can see a tree that certainly has emerald ash borer in it, but doesn't have the bark completely stripped away, but has some woodpecker signs. So a really good site to do this work. So how are these released? So it's kind of fascinating the way that this all works, is that the lab in Michigan ships us these small bolts of ash logs that they've reared the parasitoids in. So the parasitoids are underneath the wood when they come to us. And we monitor the growing conditions and the growing degree days present on a site and have these shipped out to us. And we basically affix them to the trees. And those parasitoids naturally emerge from those bolts. And they start to take advantage of the emerald ash borer that are present in that forest. And so this repeats every 2 weeks over a 6-week span, once in the fall and once in the spring and then again in the fall. And this last year at LR Jones, we released over 4,500 parasitoids into that stand. What we do a couple years after we've begun this program, so this is a 2-year program for those releases, and at the end of 2 years, we start trying to recapture those parasitoids that we deployed and determine whether they've established a population in that stand or not. It's a pretty simple method. We use these yellow pan traps. We dilute non-toxic antifreeze, basically propylene glycol, and we can collect the parasitoids that fall into those traps. Another method is to cut a couple trees and peel back the bark, looking for the parasitoids themselves in the larvae. As I mentioned, we only started this program last year, so it won't be the end of this year, but probably early next year that we'll begin sending these traps out to determine if the parasitoids have established themselves. But the idea here is that once the parasitoids have established a population, we don't have to go back year after year and redeploy them, but they'll maintain their population and continue to keep the EAB population in check as the forest grows up around them. So I mentioned that we released this in 2 locations last year. The more central location, of course, is that LR Jones State Forest. Another location was in South Hero, where we had a positive detection. We did spring releases, we did fall releases, of course, beginning in August of last year. And this year, we don't have any new sites where we'll be establishing these, but we will be repeating those deployments in both Plainfield and in South Hero. We're going to be putting quite a bit of effort this year into finding some new sites for 2022 so that we can get better coverage throughout the state with these and help protect more ash trees. One difference going forward this year and into subsequent years is that we will not only have Tetrastichus this coming year, but we'll have all of the biocontrol species sent to us with the exception of Spathius agrilli, which is not cold tolerant enough to live up here in Vermont. But Obius, Tetrastichus, and Spathius galeni will all be released at these sites. And the benefit of this is that both Tetrastichus and Spathius, those lower insects you see, those are both larval parasitoids. So they, attack the larvae. The Obius is actually an egg parasitoid. So by deploying 3 of these species, we're actually targeting 2 life stages of emerald ash borer, which is clearly more effective than just targeting 1 life stage with 1 species of parasitoid. So very, very grateful to the USDA lab that we're able to get all 3 of these this year and in years going forward. So how do we select the site and what's required? I kind of talked about some of the things that are that were helpful about that LR Jones site, but the requirements as far as USDA is concerned is that EAB must be present, ideally in low to moderate infestation levels. Obviously, the insect EAB needs to be present there in order for the parasitoids to have something to lay their eggs into. So that first has to be confirmed. Second of all, it's beneficial if ash is a significant component of the forest. So a minimum of 25% basal area of ash present. Now, this is an ideal requirement, but oftentimes if there is a site that might be a new county or that is particularly sensitive for one reason or another, this number could be reduced to something lower like 20% ash. I've mentioned a variety of size and age classes are really important for the longevity of that forest and for the success of the parasitoids. And the amount of area that is forested, that is contiguous forest, should be about 40 acres as well. So that doesn't have to be one large 40-acre parcel. It could be connected via a corridor that has ash in it, but there has to be some connectivity to the area of release and the greater forest. And finally, no harvests can be planned on those locations for at least 5 years, so that this program could take hold and the populations of the parasitoids could build. I should also mention that we are preferentially looking at public land for these sites as well, and so is the USDA. They preferentially select those sites where it's clear that there's not going to be landowner turnover, that there's not going to be changes in the management plan, so that this can be successful. So public land is really preferential, but in some cases they might consider a private land. So just in summary about biocontrol, this is our second year of biocontrol work for EAB in Vermont, and the goal is to establish viable populations that will reduce EAB populations and allow for the regeneration of ash species. Again, we're not trying to eradicate EAB, but we're trying to reduce the populations of EAB. And we released the one species last year, but we'll have a total of 3 species being released this year. So plans going forward for emerald ash borer, we're going to continue a lot of the work that we've been doing for years now. We're going to continue with purple traps, with trap trees. One thing I hadn't talked about today is the firewood exchange program at state parks. Is that we are asking that first of all, we're asking people to buy wood on site rather than be transporting their firewood. But if you are transporting firewood to a state park, you are allowed to burn 1 night's worth of firewood, but all that other firewood would be exchanged to reduce the risk of transporting the insect to our state parks and throughout the state. So that is a good effort. And what we do with that wood that is actually confiscated is we bag that up, and at the end of the growing season, we open those bags up when the flight season is completed and look to see if there are any larvae or even any adults in those bags that had emerged. And use that as a tool to let us know where that wood might have come from. When bags are confiscated, typically there's a card that's put in there that gives that kind of information. So that's something that we're going to continue this year in our state parks. We're going to continue responding to those requests through vtinvasives.org, as well as those direct requests that come into us. And as I just finished, we're continuing and expanding our biocontrol efforts. And we'll be updating outreach materials as needed. So you can expect to see a different version of this map that's on your left here, like I mentioned, in about a month or so. And as new information comes in, that map gets updated. And as need be, we'll update other documents that we share with the public. So a lot going on with EAB. And I think I've got plenty of time for questions. So again, thanks for attending this today. And I will answer questions.
Yeah, thank you so much, Josh. We've got a couple questions here, and maybe you'd be interested in starting with the first one that relates to biocontrol from Christopher.
Okay, let me pop that out, see what we got here.
Yeah. He's asking
Okay.
if you could add Bristol to the list of sites considered for biocontrol.
Sure, I'll write that down right now. Bristol would be a new county for us, and as I mentioned, we're trying to find some public land there. So if there are some locations in mind, feel free to shoot me an email with those. We definitely would love to incorporate a site down there. And it looks like this. You want me to take that one, Ginger? I can read it myself if you like. From Chris G.
Sure.
The current recommendations, removal or treatment. I hate to wave hands here, Chris, to see you ask also which option is preferable for municipalities, removing trees or treating. And I think that that's going to come down to a municipal local decision. If you have trees that are of high value that you want to protect, then an injection is the route that you would wind up going for that. If it's an overwhelming number of trees that are infested and that are becoming a safety hazard, that's when you're looking at removals. So it is on a case-by-case basis. And I'd also refer you to that vtinvasives.org website. There's a lot of materials there for municipalities. So you might have some of your questions better answered through some of that.
And it looks like we have another question here about a particular ash tree in Manchester.
Okay, I'm reading it. So Janet has a pileated woodpecker that pecked 2 perfectly symmetrical oval holes. They're nesting. So Janet, typically when we see woodpecker activity that would make us think that emerald ash borer could be present. Pileated woodpeckers are typically not the ones that we're looking at. The pileateds are going, much deeper into the tree and not necessarily targeting those outer areas of the phloem or the cambium where the EAB larvae are. So we don't, when we see pileated woodpecker activity in a tree, that it's not a red flag to us that emerald ash borer is there. So I think that might answer that. I'm trying to see if there's anything more there. Yeah, so exactly. So the woodpecker, they could be finding wood as they're creating those nesting dens, but they're not targeting emerald ash borer.
Yeah. So does anybody else have other questions? I was just adding in the chat box information about how to reach Joanne Garton, who is the Urban and Community Forestry Program staff who provides technical assistance to municipalities. And there's also a lot more information and resources for municipalities about making decisions about how they want to handle ash on the Vermont Community Forestry webpage. So Christopher has, let's see, we've got a few more questions here.
Okay.
So Peter is asking about describing some of the success in depressing EAB populations with the wasp.
Sure. Yeah. So the biocontrol efforts have been showing that the Tetrastichus wasp succeeds at about a 50% parasitism rate. So in a given area, it can remove about 50% of the EAB population once it's established, which is significant, but still leaving 50%. So it's buying trees some time that are heavily infested, and it's definitely helping the next generation of trees have a greater likelihood of becoming a mature tree. The problem, I shouldn't say it's a problem, but one limitation of the Tetrastichus wasp is that it does have a relatively short ovipositor. So that means that it can really only pierce and be successful in trees that are rather small, like less than 6 inches dBH. And for that reason, that's why there's another larval parasitoid in the Spathius genus that has a longer ovipositor that can help with some of those trees that have thicker bark or that are larger. And so using the whole suite of the 3 biocontrol species is really the best way to reduce the EAB populations. The challenge with a lot of the biocontrol work right now, people want to know how is this saving trees? What's the survivability? And that's kind of hard to tell in some of these areas where the biocontrol program nationwide is about 14 years old. So we haven't achieved that level of progression within a forest to see what the long-term effects are of tree survival and how large some of the saplings or regeneration can get even in the presence of EAB. So the jury's still out on that, but we are seeing some very successful reduction in EAB populations by using these biocontrols.
Thanks, Josh. And Christopher has another question about whether insecticide treatments support or hinder the biocontrols.
Well, that's a good question. One thing that I often tell people is that by introducing the biocontrol program, we are not putting pesticides at the same time typically as the biocontrols. The assumption I would have is that if you're injecting a tree with insecticide, you're already killing the EAB larvae within the tree. So it would hinder the success of the parasitoids being able to lay their eggs in viable material. So I can see it from that mechanic standpoint. I'm not familiar with too many sites where they've done both and looked at those effects though.
Yeah, and then I think we might have time for one last question from Ken Perot in Windsor. And he's wondering if it's preferable, or if we know whether it's preferable to locate the purple traps at lower elevations or higher elevations.
Well, elevations, that's, I don't know that we have much data on actual elevation in terms of above sea level kind of elevations, but in terms of canopy structure, uh, these insects, they fly, they do gravitate towards the tops of the canopies. So you probably have better odds of hanging a trap higher in a tree than lower on the tree. But really, it's more based on uh, where you have ash and where you expect activity to be. So I would target your traps in the upper reaches of your forest canopy. I don't know that I would focus so much on focusing on a lower elevation versus a higher elevation, but perhaps looking at those areas where you might either have more sensitive site that could be impacted more heavily by emerald ash borer, or if you're talking about a distinction between where you have white ash versus black ash, those are both important to know about. So you might put a trap at each of those, but it's really the canopy height and location of ash more than elevation, as far as I know.
Great, thank you so much, Josh. Well, unless there are any more questions, I think we'll wrap up there. This was really helpful, and I wanted to let everyone know that we will be sending out tomorrow. You will receive a recording of this webinar, and it will also be posted on the Urban and Community Forestry's YouTube page. So if you know of somebody who was interested in this, but they didn't get to register for it, we can send them the link to that. So yeah, with that, thank you all very much for attending. And Josh, thank you so much for sharing. This was really informative.
Yeah, thanks for having me.
All right. Well, take care, everybody, and enjoy this beautiful weather.